Okay, so hello everyone. Today we are gonna discuss a very important topic in electronic communication, that is radio wave propagation. I hope you all will enjoy this presentation. So without wasting time, let's get started. These are the contents that I will be discussing with you all in this presentation. Introduction to radio waves and polarization. Here I will explain what are radio waves and its polarization, how they are polarized in bounded and unbounded media, what are the importance of antenna in transmission of radio wave signals, and so on. Radio wave propagation. How the radio wave propagates, its behavior, effect on radio waves through medium, etc. And classification of radio waves on the basis of frequencies: high frequency, low frequency, ultra high, etc. and so on. Different modes of propagation: ground wave, sky wave, space wave. All I will be discussing in details in the upcoming slides. In the conclusion, the importance of radio waves in our lives. This you can see the wave spectrum. It is a range of all types of electromagnetic radiation arranged on the basis of frequencies and wavelength. This picture depicts how the electromagnetic wave propagates, and it is comprises of both electric and magnetic field. Introduction to radio waves and polarization. Radio waves are the type of electromagnetic waves or radiation in a frequency range of 10 to the power minus 3 Hz to 10 to the power 16 Hz, and the wavelength ranging from 3 into 10 to the power minus 8 meter to 3 into 10 to the power 11 meters. Radio waves comprises of both electric and magnetic fields. These two fields are at right angles to each other, and the direction of propagation is at right angles to both fields. As you can see in this picture, the electric field is blue colored, is in y direction, y axis, whereas magnetic field red colored is in z axis. The propagation is in x axis. You can see the plane of electric field defines the polarization of the waves. The polarization describes the way the electric field of the radio wave is oriented. In some cases, especially waves that are generated by natural source, the fields vibrate in multiple random orientations. They are said to be unpolarized. But when the waves are generated or pass through intentionally polarizing device such as an antenna, the fields are restricted in movements and are said to be polarized. You can see the antenna here fixed, how it is polarizing the radio waves in horizontal manner: vertical, dual, cross, right circular, and left circular. Basically, polarization are of three types: linear, circular, and elliptical. Electric field confined to a single plane in the case of linear polarization. In circular, the two components of electric field are at the phase difference of 90 degree, and in elliptical, two components of electric field are at the phase difference less than 90 degree. What are radio wave propagation? Radio wave propagation is the behavior of radio waves as they travel or propagate from one point to another in various parts of the atmosphere. As a form of electromagnetic radiation like light wave, radio waves are also affected by the phenomena of reflection, refraction, diffraction, absorption, polarization, and scattering. Radio waves propagate outward from antenna at a speed of light waves. The exact nature of these waves determined by the transmission medium. That is, in free space they travel in a straight line, wherein in atmosphere they generally travel in curved path. In unguided medium, the radio waves propagate in TEM mode. In TEM mode, electric and magnetic fields are transferred to the direction of propagation. While in confined or guided medium, radio waves do not propagate in TEM mode but in TM or TE mode. What is TM and TE mode? In TM mode, magnetic field is transverse to the direction of propagation, while electric field is normal to the direction of propagation. While in TE mode, electric field is transverse to the direction of propagation, while magnetic field is normal to the direction of propagation. These are the uses of radio waves in FM, television, military communication, mobile phones, wireless, etc. Some more uses of radio waves in living room: cordless telephones, Wi-Fi boxes, hair dryers, in bathrooms, in kitchens, microwave ovens, induction hobs, and so on. Now you will be keen to know that how these waves transmit from one place to another. What role does the antenna play in their propagation? I will explain in brief through the animation video in this next slide.
Antenna. Antenna is a vital component of any communication system which is used at both transmitting end as well as receiving end. Antenna is basically a conversion device and is made up of a long conductor. At the transmitting end, it converts electrical energy into electromagnetic waves and then radiates into free space. At the receiving end, it receives electromagnetic waves and then transforms them into electrical signal which acts as input for receiver. Antennas are basically of two types: dipole antenna and dish antenna. Dipole antenna is omnidirectional and used in the transmission of radio waves, whereas a dish antenna is a directional antenna used typically in radars and satellite communication.
Now I tell you the gist of this video. In this video it is explained that antenna is fixed at both transmitter side and receiver side, made up of long conductor. It converts the electrical signal into electromagnetic radiation and radiates in free space. The receiver antenna receives electromagnetic radiation and transforms it into electrical signals, which acts as an input to the receiver. It is the electronic device, phone, TV, radios, that receive these electrical signals and convert them into original multimedia message sent by the sender or user in the form of text, messages, videos, and etc. Further, antennas are of two types: dipole and dish type. Dipole are used for the transmission of radio and dish type for radar communication and satellite communication. Now moving to next slide. Classification of radio waves. Radio waves are classified on the basis of frequency: extremely low, infra low, very low, low, medium, high, ultra high, super high, tremendously high. Extremely low with a frequency range less than 300 Hz and tremendously high having 300 GHz to 3000 GHz. Ground wave utilizes the frequency range from extremely low to medium frequency range, whereas sky wave uses high frequency radio waves, whereas space wave uses very high frequencies up to tremendously high frequency waves. These are the applications of these waves, radio waves, on the basis of frequency classification. They are merely three modes of propagation of radio waves: ground waves, sky waves, and space waves, also termed as line of sight waves. Ground wave utilizes very high, low, and medium frequency, whereas space waves uses high frequency, very high, ultra high, and sky waves uses extremely high frequency, that is 2 MHz up to 30 MHz. Now I will be discussing all of three modes of propagation in details in the upcoming slides. Ground wave propagation. Ground wave propagation is a method of radio wave propagation that uses the area between the surface of the earth and the ionosphere for transmission. The ground wave can propagate a considerable distance over the earth's surface, particularly in the low frequency and medium frequency portion of the radio spectrum below 2 MHz. Earth is assumed to be an ideal conductor. The EM waves cannot penetrate the ideal conductor. The EM waves cannot penetrate the ideal conductor. This phenomenon is termed as skin depth. Skin depth is a measure of depth to which electromagnetic waves penetrate into the medium. That's why the ground wave propagation is possible, due to reflection, diffraction, attenuation, diffraction, etc. The ground waves are transverse in nature. Horizontally polarized antennas are not preferred. This is a very important point, because the horizontal component of electric field is in contact with earth, is short circuited by the earth. Therefore, for the ground wave polarization, vertically polarized antennas are used. These are the advantages and disadvantages of ground wave polarization. Advantages: given enough power, they can be used to communicate between any 2 points of the world around the world. They are relatively unaffected by the changing atmosphere conditions like sky waves. In this picture you can see 24 hours a day, 7 days a week. mobile technologies at our fingertips. In this picture you can see the ground wave is in line of sight, this, and the sky wave is reflected through the ionosphere and then reaches the boat. In the below slide photo, sorry, you can see the red wave is in the line of sight, whereas the blue wave is comes to the house after the reflection from the hill. Clearly the red wave will have the greater signal strength, whereas blue wave will have a low signal strength, because due to reflection, and many other and attenuation, etc. What are the disadvantages of ground wave propagation? Requires relatively high transmission power. They are limited to very low, medium frequencies which require large antennas. Large antennas means large cost, high cost. Ground waves get attenuated due to Earth's imperfection. Absorption and reflection by the Earth's surface and attenuation increases with frequency by the tilt in the wave as it progresses along the curvature of Earth. Due to horizontal component of electric field get shorted, which reduces the strength of electric field. You can see how the radio waves get attenuated by the factor of e to the power of minus alpha z due to reflection and many other properties. Sky wave propagation. The sky waves are reflected from ionized layer of atmosphere back down to the Earth's surface and is useful for very long range distance communication. They can travel number of layers back and forth between ionosphere and Earth's surface. The sky wave, often called ionospheric wave, it is either the reflected or refracted back waves to the Earth from the ionosphere, which is electrically charged layer of the upper atmosphere. Ionosphere is generally the upper part of the Earth's atmosphere with an having altitude 60 km to 1000 km. It is ionized by solar radiation. It consists of three main regions, that is D, E and F. D region usually forms upper part of mesosphere, whereas E region appears in lower thermosphere, whereas F region is in upper thermosphere. Application of sky waves in satellite communication, mobile communication, and so on. Now the question arises: the radio waves are reflected from ionized ionosphere to the ground, back to the earth after the particular distance. That distance is termed as skip distance. We will be discussing about the skip distance in the next slide. The minimum distance from the transmitter to the point on a ground at which the given frequency will return to the earth by the ionosphere is termed as skip distance. The formula is 2h under root f MUF upon FCR whole square minus 1. Whereas f MUF is maximum usable frequency, where FCR is critical frequency, and h is the height of reflection at which the reflection occurs. Critical frequency for which the layer is defined is the highest frequency of wave that will return to the earth by that layer having beamed normally at it. It is given by this formula. Whereas maximum usable frequency MUF is defined as the highest frequency at which it is reflected by the ionospheric layer by the angle of incidence other than the normal incidence. Its formula is given by Fc into sec theta. Keeping all these values, we can calculate the d skip, the distance after which the electromagnetic waves, radio waves reflected through the ionosphere. Now we will discuss about space wave propagation or line of sight. Space wave propagation is defined for the radio wave that occur within the 20 km of the atmosphere, that is troposphere, comprising of a direct and reflected waves. You can see this is a direct LOS space wave and this is the ground reflected wave. The waves are also known as tropospheric propagation as they can travel directly from the Earth's surface to the troposphere surface of the Earth. It is also known as line of sight propagation as the signal are sent in a straight line from the transmitter to the receiver. In order to prevent attenuation and loss of signal strength, the height of the antenna and the distance between them can be given as 1 upon under root 2r st plus 1 upon under root 2r hr, where st and hr are the height of transmission antenna and receiver antenna. Space wave propagation depends on three components: direct wave, ground reflected wave, and tropospheric waves. It is direct wave, ground reflected wave, and tropospheric waves. Direct waves, the radio waves that are transmitted from the transmitting antenna reach the receiving antenna directly, whereas in ground reflected wave, the radio waves that reach the receiving antenna after reflection from the ground, and tropospheric waves, the radio waves reach the receiver antenna after the reflection from troposphere. Now in this slide I will be discussing the impairments to the line of sight propagation. Impairments mean loss of signal to the space wave from space wave propagation. Low powered microwave transmitters can be faulted by the tree branches or even heavy rainfall or snow. The presence of objects not in the direct line of sight can cause diffraction effects and disrupt radio transmission. For the best propagation, a volume known as fractional distance should be free of obstruction. You can see here is a transmission antenna, here is a receiver antenna. The line of sight is blocked by this road traffic, trees, etc. It can be corrected by two major steps. We can increase the height of the antenna, or we can clear all the obstacles that are coming in fractional zone. What is fractional zone? In a point to point wireless communication, it is important for the line of sight between two wireless communication to be free from the obstacle like vegetation, building, wind farms, etc. As an any interface of obstruction in loss can result in a loss of signal. While installing a wireless communication system, it is important to keep an elliptical region between the transmit antenna and the receiver antenna free from any obstruction for the proper functioning of the system. This 3D elliptical region between the uh, transmit antenna and the receiver antenna is called fractional zone. The size of ellipse is determined by the frequency of operation and distance between the two sides. Now I'll show you what is the formula to calculate radius of this ellipse. The radius is given by 17.3 into under root d by 4f. What is d? D is the distance between transmitting antenna and receiver antenna, whereas f is the frequency transmitted by the transmitting antenna. By this formula we can calculate the radius of the elliptical zone or fractional zone. Now we are concluding this presentation. Radio waves signals are mainly used for communication purpose, starting from the transmission of television broadcast signals to the communication with aircrafts. Every mode of communication and transportation is dependent on signal transmission in radio wave frequency. The main objective of the radio wave propagation is to transmit signals securely without any error. The mobile phones use radio signals for communication purpose. It can be concluded that radio wave propagation is an important branch of communication studies. In this picture you can see the simulation of radio waves as seen from the earth by the satellite. These all are from my side. Thanks for watching the video.